So, hello, everyone. I hope you are doing well and you're fit and fine. You're solving questions. I hope your exams are going well. I think this is the exam time, but yet you are solving GFG POTD. So, you are doing good job. And if you are solving these kind of problems, will definitely make it to a good placement. So before starting of the video, if you're new to the channel, make sure to hit the subscribe button and like the video because we make content around DSA tech and we make intuitive and innovative solutions for you guys. So make sure to watch till the end as well. So I will show you a very unique solution for this. Nobody, it's a like O of one solution I will show you, or not O of one space complexity solution. And yet you heard me right. No stack required. No stack. I will show you a very elegant solution. Nobody must have solved that. So stay tuned till the end. That's how I'd approach it. Right. So you're given a string S consisting of the characters this, and your task is to determine the minimum number of parentheses, either this or this, that must be inserted any position to make the string a valid parenthesis. Okay, fine. A parenthesis string is valid if every parenthesis, opening parenthesis, have a closing parenthesis, every closing have a opening parenthesis, and parentheses are properly nested. So what they're trying to say, it just we know that what a balanced parenthesis is, right? What is a balanced parenthesis? Tell me. It's simple, right? Just it's a opening. Every opening has some closing bracket. So every opening has a closing bracket. That means that is a balanced parenthesis problem. And it's a very famous problem, right? How do you solve it? You solve using stack data structure. But do you actually need a stack data structure? I will tell you a very interesting solution that you will think, oh, why do we need stack? I'll show you how to do that. Okay. Before that, let's try to quickly go through that solution that I will how I'll check through that an elegant solution, and then we will see this solution is just a variation of that problem, nothing complicated. So let's see how you solve quickly the balance parenthesis problem using my elegant solution. What do you initially do in a balance parenthesis problem? That whenever you get this kind of character, you push into the stack, right? This is we do because how do you do a matching? And whenever you go closing bracket, you check your string, your stack. Now there could be two kind of scenarios, right? Either your stack is empty, then what you have to do? You have to say, oh, this is false. That it is not valid, right? You have to return false. Or else what you do? You just pop it out, pop out. This you generally do. And what at the end what you check? If s dot size, as I'm assuming the stack equals to 0, then what you do? You return true. Right, it's a valid balance parenthesis. This is a standard pseudocode of whatever you want to do when you are checking a balance parenthesis, right? But do you actually want a stack? Why you want a stack? You are just what you're doing. You're inserting same number of elements. You're not inserting index also. You're just inserting this. Why you need that? Have you thought about it before? Tell me in the comments that have you thought about it? Why you need a stack? You just memorize the solution, right? But do you need it? I will show you another idea. Instead of using a stack, you can use a simple variable, right? In prefix. So what it gonna do? It's gonna do the same thing. It's gonna do the same thing. So what are you gonna do? If you found this, what do you do? A prefix plus plus is same as pushing the element, right? And then if you found this, you check if prefix is 0. That means return false. It's not possible. Stack is empty, right? It's same as that, right? And if elsewise, what you do a prefix minus minus. It's same as popping out the operation, popping out the operation. So do you see a similarity? It's just that simple, right? And then you just check whether prefix is 0 or not. Whether you're checking size, right? You just check prefix or 0 or not. This is does matter, and this is the solution, right? This is the fine. This is balance analysis. Now let's come back to the problem. The problem says it's we need to make it valid. Okay. So what intuition that comes to your mind? Firstly, this intuition should come to your mind. Balance paralysis problem I have solved very clearly. Now how I can solve this problem? Hmm. When I'm solving this problem, let me using the elegant solution. Okay, okay. This is a problematic thing, right? This is a case where is a problematic thing, and this is also case of an a problematic thing. This will check at the end. This is a problematic thing. That means there is no opening bracket corresponding to a closing bracket. What is happening is that this, and this is happening. We don't have an opening bracket corresponding to it. Since we can add anywhere the opening bracket, so I will add it here. This is I costed. So whenever you get this kind of scenario, instead of returning false, just maintain a counter and do a count plus plus. It's that simple, right? These are the operation, right? Where your code is failing. Prefix is still zero. Prefix will be still zero, right? Because you have to do a minus minus, but it's already zero. You cannot do a minus minus. That means you do a count plus plus. Count is storing our final answer, right? It's that easy when you think about it. Yeah, it's very simple. Yes, you got it right. Then what you wanna do? It's very simple. Again, there you go to prefix zero. Oh, how many elements are left? Because suppose it could be like that. There could be extra this kind of operations, right? So this is balanced, but these are unbalanced. So what are you gonna do? You're gonna add these things to your, so whatever prefix left at the end after the for loop, you just add to your answer. That's it. And just you return your count. So you do let me know that if you found the solution helpful. We'll go quickly to the code as well. And if you like that solution, make sure you hit the like button, because that like helps me to keep motivated and provide you these kind of good solutions. So quickly let's see the code. It's very simple, not much complicated. I'm saying again and again very simple because it is actually right. And then what are you gonna do? You maintain a counter, you maintain a prefix. Then what are you gonna do? This if C is there, increase the prefix, same in pushing. This is the same as push operation. And if prefix is zero, that means your stack is empty. This is known as stack is empty. Checking stack is empty or not. If it is empty, then what are you gonna do? You have to insert something. You have to do a count plus plus plus. Means you're just mapping. There's an extra closing bracket. There's no opening bracket corresponding. So you're adding a opening bracket corresponding to it. Elsewise, you're doing a prefix minus minus. You're doing a pop operation here. And at the end, whatever is the extra opening brackets is remaining, you just add to the count, and finally your job is done, right? So I hope you understood the entire intuition. Firstly, I explained you the code, means the intuition that this is the elegant solution I prepared. You can do with the stack example as well, but this is more easier, more better, more efficient, oh, one space complexity. So yeah, this is for it for the today's video, and we'll see you in the next video. Stay tuned.